Hey there, and welcome back. Welcome back to episode number 3. In this episode, we're going to actually create data inside of Unity. Let's first finish off our vertices and triangles, because that's something that we need. In order to finish it off, we need a list of integers of triangles here as well, because with just vertices, we're not going to draw triangles. Now, in order to render these triangles, we need to reference the correct vertex index. So we need some sort of like an int that keeps track of like our trie index. So we just call this one trie index and initialize it to 0. Now, in here, in order to create the triangles, we're going to do triangles.add trie index. So this is now our first vertex here. Then our second one will be triangles.add trie index plus 1, which is going to be this one. First index, and that will generate one triangle, is trie index plus 2. I think that sounds pretty logical. Let's copy this over, because 2 triangles form one, like little plane. And this one is going to be 2, 3, 0. So 2, 3, 0. And this generates the top side of every block. Now we just have to increment our trie index by 4, because, well, we're adding 4 vertices, and that's our offset on every single side. Alrighty, I hope that makes sense. Now there's one thing that we need to do in order to get this one to work inside of Unity. And that is go under our for loop, and this is all going to be replaced later on. So yeah, just don't remember what I'm typing here, and it will all be changed. Now I already changed our game manager a little bit, so I included a public material base material. So we can reference this for debugging purposes, but also this one will be gone later on. Let's go back to chunk rendering. So let's create a new game object. Since we're in the main thread, we can do this. Geo is new game object. We call this one chunk, and let's go and add our chunk.position, not char, chunk.position.toString. So we can see which scale object we're dealing with. Let's also make sure that we set the correct position for this chunk. So we set the go to transfer position equals the new vector tree, which is going to be our chunk.position.x times our chunk.size, chunk.position.y times our chunk.size, and our chunk.position.c times our chunk.size. Because then we are at the correct world position for our chunk. Now, after we've done that, we just need to add to the mesh renderer and the mesh filter and to create a mesh. Let's first create a mesh. Mesh is new mesh. Mesh.set vertices, because we first need to set the vertices, and we set it to the vertices. Do the mesh.set triangles in order to set the triangles, and we set it to the submesh of 0, since we assume that we are not going to generate more than 65,000 triangles. I hope. Now we're going to do the mesh.recalculate normals, but we are going to manually create normals, because for example on the top side we know that the normals are always facing up, since it's, well, voxel style and micro style, so it's all hard and very like same every time, same old. And if we've done that, then we're actually done. We can call this mesh.apply, or what was it called? There is like a function in here that I don't know what it's called anymore. Upload mesh data. Mark no longer readable. For now, we can set this one to true, but later on, we're going to have dynamic meshes, and we're only going to create the mesh once, and we are going to do this set vertices, set triangles, and clean it, and that kind of stuff. But we're going to modify this one, because we might only remove a certain triangle set. Since our voxel will know which triangles it spawned in the previous iteration, we can store it in our voxel and just remove that one from our vertices list and just recalculate without having to go over a whole for loop if we just add some or destroy something, because that's our main purpose of this. Let's do the go.add component mesh filter. Now our mesh filter, let's save it here, and we set our mesh to our mesh. And of course, we also need a mesh renderer. I call it renderer. Equals to go.add component mesh renderer. And then we set renderer.material equals our game manager.instance.base material. As you recall, I just talked about this one. This is just this base material, and this is a singleton, so we can access this one easily. And it's just so it's not going to be pink. Now that we got this, and we have our triangles, we have our triangle index, we actually will be able to see this data. You've seen this. I was actually stupid, and I thought I did something off camera, but this was just done in episode number 2. So, you know everything right now. So, we can go into Unity, check our game manager, or check our project. I've got this created material here. It's called base. It's just a standard universal render pipeline lit material, no changed properties. I assigned it to the base material here. Press play. And now we got a wonderful little white plane. Well, that's actually pretty epic. It does not seem like a lot, but this is cool. This is really cool. Now, if I change our function with our getVoxel to return a new voxel of type stone, for example, if we go over, we will not see anything because it thinks that there's like something there, and because it thinks that there's something there and there's something here, and okay, that's really hard to explain, but it will say that it should not render because it is just not needed to be rendered. So now you don't see anything, and that's a good thing. If you're not sure if you should render something, don't render it. Not always the case, but in this example, it is definitely the case. Now let's go back to our chunk renderer class, and let's be a little bit dirty here. Let's just copy and paste this over. There is a way that we can easily just like make this function on one place. But for reasonings that I don't want to do that right now, because we're going to rewrite this everything what we do here later on to be like more special and more specific and faster. We're not going to worry about that just yet. Let's check the bottom side. So we will add comments here. So check if we have air. Ooh, if I can type at least. Check if we have air below our current voxel. So we should change this one to -1. And then we remove our +1s here. Because, well, no, okay, I suck. Because now we're rendering the bottom side. And this right now should render, theoretically, our bottom side. But take a look at this. Take a look at this. And this is what I meant with like we will optimize this, but that's actually still pretty hard. Because it has to do with the order of the vertices. Because we kept our same XYZ drawing order, it will still render to the top. Because Unity has a clockwise rendering method, our first point is left bottom, so we can see our grid here. So this left bottom here where my cursor is at right now will be the first one, second one is here, third one is here. So that means that this will be rendered to the top. If we want to render it to the bottom, we should have like our first point here, second point here, third point there. So exactly the other way around than how we do it right now. So there's a decision that we need to make. Add our vertices the other way around, or swap our triangle order. It really doesn't matter what you do right now. Just do whatever feels good. You can just swap this 2 and move it up, and this thing here. But what I'm going to do right here is actually swap our vertices around. So in order to do that, you can actually just do this, this, and this. And now I got them swapped around. Just swap them around. And then it's all fine and set. Because if I run it now, hit shoot, because I always fuck this part up, but this should be okay. And now we should not see the top side or the bottom side from the top, but we should see it from the bottom. Yes. Yeah, you can say whatever you want about this approach, but again, it really doesn't matter. It really doesn't. At least not that I'm aware of. If you think differently, just make sure that you let me know. And I also see that I made another mistake here. I put a 0 here, which should of course be our z-axis. Otherwise, that would have been a big-ass problem. And this should all be ifs and not else ifs, because it might have no top and no bottom. Now, let's go in our correct order. So our x-axis will be above here. So x plus 1. That means that we are going to render. Check if we have air on the right side. This means that we need to render our right side of our cube. Now, let's get our initial vertex order, because this was to render the top. Now, if we now think about this and we go to Unity, we have to think about this order, because this order is really important. Like if you create a cube, and you go here, and let's create another cube under here, and let's make this one 0.1 in size. And let's move this one here. So in order to render, we have to know that it's rendering in the clockwise order. So if this is our first point, then we know that we have to go minus x. Well, yes or no, it really doesn't matter where we start, because we can start here. But we should start at the top, because we're at .5 now, and it's halfway in. And, well, this z-axis is backwards or forward, but our z-axis is... Wait, I should do it to the correct side, because I actually almost visualized this on the wrong side, because we have to work it here or here. Because we're on the plus on the x, so the x-axis we're not allowed to move, and we're on the plus on the x. So it should be on this side. So we can start here with our 0z, because this actually is 0 if we move our cube over, but we don't have that. And then we go to here. So we go from 0 to 1z, and then we go down. So we go from the up position, which is this, to up plus 1, to, well, never, like, this is always the case in this example, to down. So we have on the right side, up, same z, right side, up, go backward, right side, bottom, right side, backward. So this is the bottom right. And now we need our bottom left, which is this. So now this should theoretically generate our right-hand side triangle. Let's check it out. And again, this is the part where I make mistakes as well, because sometimes I'm just a little bit of a, well, weird person in this part, and it's just a little bit of a trial and a error, so to say. So there is our right side. And it is the right side because this is x plus, and it is actually correct. So we're just generating one massive ass cube right now. Let's do the same for our left side. And the reason that I just show you this all is because this, as you can see, it's not just copy and pasting. Because if we do this on the left side, we should remove our x plus 1. And as you can recall, if we should render the other side, we can just flip it, right? Yeah. So if we just get our first 3, copy it up, we get our middle 2, we get it up, and we get our 1, and we get it up. This one is flipping it. So this right now, you think, should render our left side. We did x minus 1. We removed our x's here. So this should render our left side. So let's check this one out. Let's press play. And we have our left side, because this one is completely at the Z line and it is at the left, so this is our left side. So now we got 4 out of the 6 sides done. It's only the Z axis left. So let's go to our Z. So let's get our normal aligned one first, because we know that we need this order in order to draw the front side again. And so this is check if we have air in the forward direction. Yeah, it is C plus 1. So now in order to get this one to work, so let's go and remove our y plus 1s, because this is going to be different every time. And now where we have our z plus 1, I think we can do this and this. Okay, so right now I just did a big ass gamble here. So let's debug this. So now we're at the bottom of our cube. And now it's in the z-axis, so where the blue arrow is pointing to. So we're at the bottom. And now let's see where we're starting. So it's at the bottom at that side where x is starting. So that is here. So we're at the left bottom here. Now, if we watch it from this side, if we start at the left bottom, we need to go to the x plus 1 first. That's correct. Then we need to go up. And then we need to go with the z. Yes, because... Okay. So x plus 1, yes. Then x plus 1 plus y plus 1, yes. Then back and y... Yes. This should be correct. So the only thing that I did was just flipping some values because, well, that sounded logical as well. And then we should have... Yes, we do. Our correct side. Now there's one more to go. So we can just copy this over. Call this one our backward direction. Copy our 3 below. Paste them in. Middle 2. Paste them in. This one. Paste them in. And put this one on 0. Oh, wait. -1, yes. And then remove this plus 1s. So we're rendering our backward side, or the side where we're facing to right now, and if we enter the environment. And this is actually our left side. Above, below, forward, and backward. And now we should have a big cube of 32 by 32 by 32 meters. Very special, right? I know what you're thinking. This is still pretty boring because, well, you could just do this, right mouse button, cube, scale. Woo, I got my cube. Yeah, this one is a bit off-centered because if I move this one to 16 by 16 by 16 now, as you can see, we generated the exact same cube as this one. Yay! Was that worth 3 episodes? It definitely was. Because, let me show you something. This rendering method is pretty smart, and right now we're going to remove some things that we did wrong at the beginning, and that has to do with this getVoxel method and then returning voxel 1. Because returning voxel 1 means air, and we need to return stone, which is 0 for now. So it just knows that it needs to render nothing if we did not load our chunk next to us. This means that if we press play right now, we're not going to see anything. And we're back to square 0. Which is fun. Because that means that we can remove one block in our voxel thing. And we can see it in action. Because now if we go to our chunk. And if we call this. And let's just do this. Private void handle main chunk. This is super duper ugly. If position equals vector 3.0 handle main chunk. And then we go for int x equals, let's say 10, x is less than 20, x plus plus. For int y equals 10, y is less than 20, y plus plus. And for int z is 10, z is less than 20, z plus plus. Let's do our voxels x, y, z equals new voxel. And set u to air. Now we make a square hole, so to say. Before we render it, of course, because otherwise it will be weird. And now we will have a area. A playable, actually playable area. It's just a hollow area, but that doesn't matter. As you can see, there's something here. There's an inverse cube now. But this is the power of the voxels. Because in the next few episodes, we're going to do like texture drawing and materializing things. And we're just going to rip off Minecraft textures. And I'm going to show you how and where you can get those and do everything so we can just easily show it. Then we're going to set up some scripts that will actually read metadata so we can actually start mod support for this. Because that actually starts to be very important sooner than later. But as you can see, we can generate infinitely amount of content right now already. Because this, now we just generated one chunk, but you can create as many chunks as you want, and that is actually creating this whole system. So, hopefully you've learned something, hopefully you've enjoyed a bit, and hopefully you can't wait for the next episode, just like me. If that's the case, don't forget to leave that like. So, see you the next time. Goodbye.